Okay, I think we are live. Wait for the sound. We are live. Okay. Okay, so this is a very late night session. I couldn't sleep and decided to instead do this. And you can see that like I have this very yellow light lamp in my room, which is okay. But yeah, so coming back to what we are going to discuss today. So these days I've been tweeting a lot about these system design problems, and these are pretty good problems that are like commonly asked in interviews. And these are not very straightforward problems in the sense that it's not a problem where you just tell that design a Facebook like system or how would you design Instagram. So these problems are not like that. These are very nuanced problems, and so the tweets that I've been making are mostly about the production, about the problems that we face in production from day to day. So, uh, yeah. So you won't hear about these problems in the interview, but you will face them in production at some point of time in your career, given that your career is long enough and you are solving problems. Uh, I wouldn't say scaled, like some of these are scale based problems, but most of them are just implementing things correctly. So enough scale to implement things correctly and yeah, and test your implementation against the traffic that you get. So we will be discussing two problems today. So 8 hours ago, I made this tweet, and first of all, I would like to do a shout out to everyone who is participating in these discussions. My goal is to answer each and every reply. My goal is to answer to each and every reply that I get here in these discussions, and I want to keep them as detailed and healthy as possible. And yeah, I see like many people uh, use like ChatGPT or AI LLM tools to like write the answer, but that's okay. As long as you're learning something, it doesn't matter. Um, okay, so this is the problem that cache hit rate is 99%, but our API is still slow. And users complain that the response time is 2 seconds. And where is the bottleneck and how will you fix it? So basically, what is happening is I don't know if I can paste it here. So this is one of the first sessions that I'm doing, and I plan to do more like these, where I just tweet about some system design problems and then, uh, yeah, and then try to make a video out of it to explain how to solve these problems. But your API is still slow. Users complain about a 2 second uh, response time. What is the bottleneck? So this is the problem that we have a caching, like we have caching enabled in our system, and it's fine, it's working fine, and cache hit rate is 99%. Like yeah, like 99% of the time you hit your cache, like you find the data from your cache directly. So yeah, just to explain this in simple terms, so this is our cache, which is like, let's call it Redis, and this is our DB. Okay, and like we have users here, and like request comes to our like backend system. So this is our whole backend system, This is the backend system where we have our database and then a Redis cache on top of the database. So whenever a request comes in, it hits Redis and it tries to do the lookup in Redis itself. And 99% of the time you are able to find the data in Redis. But for 1% of the time that you are not able to get the data, the request goes to the database. And when it is returned, when it is returned to the user, um, yeah, I don't know what is this hand gesture thing. Gesture, turn on reactions to express yourself with a hand gesture. Okay, I don't need it. So what happens is that 99% of the time our data is returned from Redis, but for that 1% of the time, the data is not there in Redis, and it goes directly to the DB for query, and then it returns the data to the user as well as populates Redis. So this way we are able to uh, like serve the request directly from Redis. So for, let's say that some Amazon sale is going on or something, some e-commerce sale, and we want our data to be in Redis because like lots of, we will be expecting lots of requests. So we want that, like that inventory, whatever we are selling, like some hot items, for example shoes or whatever. So we want that data to be in Redis because we will be serving that a lot to the customers. Like we will get a lot of requests and we want that data to be returned to our customers pretty quickly, so we can't bombard the DB with all the requests. So we want that in Redis, and 99% of the time we are getting the response properly. Like we are able to see the data in Redis, but for that 1% of the time when we are not able to see the data, we are making database calls. So that is a problem, and because of that the response time is 2 seconds. So like Redis offers sub-second latency, so like it will, like even milliseconds or nanoseconds it will serve the request, but still we are saying that 2 second is the response time. So what is the bottleneck here, what is the issue here, and how will we fix this? So that is the problem, and like many people have given very good replies, but one of the reply is correct, and it's about uh, yeah. So what happens is that when, yeah, so what happens is that, let's say like all the items we have in Redis, uh, let's say like there are some hot items in Redis which have a TTL of, let's say, 15 minutes. Yeah, it's difficult to draw here. So like after 15 minutes what will happen is that our those items that are there in Redis will expire. So they will be evicted, and then we will experience cache miss. So instead of like hitting and getting the data directly from Redis, we won't see it there, and we will be requesting that data from database itself. So that is the problem, and we are not handling this cache invalidation. So, and this problem will occur every 15 minutes. So every 15 minutes, like we have some hot item, let's say some Nike shoes or something that is requested a lot, that is being requested a lot, and like we have hundreds of requests coming in to get those Nike shoes, to know about their status, their count, or simply their information, like metadata related to it, like what shoe sizes are available, who is the seller, etc., etc. So all of that data is in Redis for 15 minutes, and TTL is 15 minutes. And like after 15 minutes, what will happen is that it will expire uh, out of Redis. So like the data won't be there, and then we will, like all those hundreds of requests, they will be hitting our database directly, and that is a problem. And because of that, like since so many requests are there, some of them will even fail because there is so there is this thing called connection pooling. Like many people have answered this correctly, but mostly I was looking for this term here, invalidation. So like every few minutes uh, that data will be invalidated and we will be hitting the database directly. So we want our database to be as fast and as available as possible. So first of all, one thing is connection pooling. Um, so we want connection pooling here. I'll just remove this. Yeah, so the first thing is connection pooling. First of all, we need to have a connection pool for our database, because if you're expecting a lot of requests to the database, you can't just keep on opening new connections to the database, because you will soon hit some memory limit and your database will stop working. So any connection that comes in, we need to have a pool of connections, like for example, let's say 20 active connections, and every request that comes in uses one connection from that connection pool, connects to the database, fetches the data, populates Redis on its way back, and then and then frees up that connection so others can use that connection from the pool. So that is the first thing that we can do to have our database query handling uh, like be optimized as compared to some default setting. So one thing is connection pooling. The other thing is that people have also answered is serialization. So whenever we fetch anything from the database, we now need to serialize it. I don't think like this will be much of an optimization, because we anyway need to serialize the JSON response or anything. So that is okay. Uh, yeah, maybe like what we can do is, I'm not sure how correct of a solution this is, but maybe like we can serialize this with a better message format and put it in Redis, like to just have the optimal packing and unpacking as fast as possible. So that is one thing. Maybe like all our services in backend can have a better serialization model, like message pack or something, which is like more compact and fast and faster as compared to JSON. But yeah, I wouldn't like depend on this. So connection pooling is one thing that is a very good optimization, because we don't want to bombard our database with infinite connections. At one point of time, we will run out of connections, and our all the memory will get exhausted, and every request that comes in will just fail. So the second thing is like adding a jitter. So whenever so it's kind of a thundering herd problem, where if something gets out of Redis, we are like bombarding our database with all the calls. We don't want to make all the calls at the same time. We want like some difference between the calls, and for that we can have some jitter between the calls. um, Again, i don't think I don't think like this is also something that is needed. Like obviously like connection pooling is one thing, like connection pooling is the correct thing these to get this setup optimized. The other thing is like cache. I don't know what is the correct term, but maybe like cache validation from time to time. So what we want is that we know our cache is going to get expired in 15 seconds. Maybe we can have a go routine or a thread running that can just populate the cache based on the number of requests that we are getting for that particular item. It can just validate or refill the cache before it expires. So that is one thing. And obviously we don't want our cache to be like present for a longer duration of time, because because uh, like here database is our source of truth. So if there is some item, let's say like there are Nike shoes and there are 100 pairs available, so what we want is that we want that data to be in Redis first of all, because we can't keep on updating, like fetching the data from database. So like there are two different components. We cannot simply just say that we will add one Redis here and one database here or connection pooling here just without thinking, because every problem solution is designed according to the business needs. So first of all, so actually there are two things that are needed here. Let's say that we have Nike shoes, and those are very like hot items that like one of the hot items that we have during a like let's say a festival sale or something. So what we want is I'll also just check that every okay. Yeah, I think the lighting could be better, but okay. So what we want here is, yep. So um okay. Okay, so there are two things here. Let's say that we have a very hot item during a e-commerce sale, and that is available in our database along with its metadata and everything. So we don't want that. Uh, Again, maybe okay. I'll just use this. So we can't just like keep that. So there are two things. One is the metadata part, which we can obviously populate in Redis, and that is not going to change. So that is not a problem. So let's say that we have Nike shoes with all the sellers available, the information about the sellers, and also like some metadata or something, whatever is related to it, like its information, sizes, etc. So all this metadata can be available in Redis, so we don't have to worry about it because this is not going to change. The problem with the items count here is, let's say that there are 100 shoes available and there are 10,000 customers who want to buy that shoe. We cannot so obviously like all the requests can't go to the database because uh, yeah, and even if they do, like we need to lock that whole row. So one if one request tries to uh, let's say buy that item, obviously like they can put it in the inventory and then they can click on buy. So once they click on buy, once we make another uh, call to another like a payment service. So I'll just clear this. Now this whole thing is getting more and more complex. Can I like make this dark? I don't think I can. Dark mode. Create, start drawing. Okay, yeah, this is much better. That white screen was just burning my eyes. Okay, so now we have uh, Redis, and we have our DB, which is Postgres with all the information stored. So what happens is that whenever a call comes to Redis, and let's say that we have some, uh, let's call it Nike shoes. Okay, just, and let's say that there are 100 shoes available, or we can say that there are 1,000 shoes available, and then there are 10,000 customers who want to buy this. So the problem is that all those 10,000 customers, and this is let's say only a 15-minute window sale. So basically, the problem is now that how will you prepare the system for this scenario? So Where is that problem? Yeah. So this is the tweet, the original tweet, that our cache hit rate is 99%, but our API is still slow. Users complain about a 2-second response time. What is the bottleneck here? Mm, the problem is that in this 15-minute window, let's say that if there was no Redis, then what happens is that a customer makes a call, and let's say that we don't have even connection pooling in our database. So what happens is that now we will lock that row in the database. So it will be a transaction, and the transaction would be to update the count from 1000 to -1. So we will have something like a transaction, and inside a transaction, we will also make a call to our payment service. So basically, we are locking that row. Uh, okay, yeah. So what we are doing is we are like starting a transaction. So we have a transaction. Inside the transaction, we are doing three things. First, we are reading the initial state, and here the initial state is that we have 10,000 items, like 1,000 items available. And let's say, like, again, to describe the problem here, we have 1,000 items available, we have a 15-minute sale window, and 10,000 customers hit our backend at once. So what happens is that we will open a transaction on our database, on our table, for that item, where we will read the item, and then we will subtract one from that item. We will also update the item to the new value, which is 1000 minus 1. So we will do that, and we will make a call to our payment service. So we will make a call to the payment service. So this is a third party call where we have like a third party dependency, and this is our internal system database update. So once the payment call is successful, we will then end this transaction. But there are a lot of problems here. First of all, what happens when the payment fails? Now again, if and what happens, like, we are getting delayed for the payment to be so we know that the user has made the payment, but it might be the case that the payment is getting delayed. So what we will do is so n- now there are multiple scenarios, like there are tens of things to discuss here. So scenario number one, what if the payment succeeds? So if the payment succeeds and it is quick enough, this transaction is fine, but we cannot design for that. We must think of the worst possible scenario here. The worst possible scenario is that the payment takes time. So we cannot simply open the transaction with the payment here. But what we can do is we can quickly assign, so every payment that we make from our backend has a payment transaction ID or some idempotency key. So this is the idempotency that we keep talking about. You will see the whole Twitter feed filled, like, for backend questions, like you will see, and even I write about it. I won't say that like I don't write about this, but this is something very common. Like, our whole Twitter feed is filled with one thing to be learned, and that is idempotency. But what is idempotency here? This is what idempotency is all about. Let's say that you have a call on your backend, and you have a database with all the items available in the database. Let's say, like, there are 1000 items available, and some users want to buy one item out of it. So we will open a transaction, we will read the item count, which is like 1000, then we will update it to 1000 minus 1, and at the same time we will make a payment. The payment will be made with an idempotency key, and with that row in the database we will assign the idempotency key, and that is the transaction key, not this transaction key but the actual payment related transaction key. I'll just charge my laptop. Mm, yeah. So okay, where was I? So you will open the transaction in your database, you will read the current count of the item, you'll subtract -1 from it, you'll update your database, and at the same time you will attach uh, payment key, payment idempotency key. So you'll make a third party call to some payment provider. You'll create a transaction key. You'll make the call with that transaction key, and yeah, and you will then attach it to your database row, and then you will end this transaction, because you cannot wait for the transaction to complete. It might take, let's say, like, the payment provider is facing some issues, and it might take like 15 seconds or something, like 20 seconds to revert back the reply. So you will do this because you can't wait for 15 seconds. You can't wait for like 10,000 other requests to take a hold of that connection, because this transaction is still modifying your database. Okay, so that is one problem. So yeah, you will quickly attach that idempotency key to your like to your database operation that you just did. So yeah, and it will be stored in some separate table or something, like payments plus Nike shoe collection ID or whatever. So that is one thing. And what can happen is that after some point of time, that transaction might fail. So then you will have a refund flow that is like activated at a later point of time. But you must show the user that one of the item is done. So like you guys have paid for one of the item, because you can't have double spend now. You can't, let's say that you only have one item left, and like two different transactions open up, and they both try to buy the item. They both create this idempotency key, make a transaction, make a third party call. You cannot update the same item with both the idempotency key. You must update it only with only one of the keys. You can't do with both of them. So that is the thing. Because let's say that what happens if both the transactions succeed, and again you also have to handle the scenario if you mistakenly update with both the keys. First of all, like, it would be an invalid state, because for one single item we are making two different payments, which is wrong. So you must have proper refund related flow in your code base here, but that is a topic for but that is a separate discussion topic which we will again discuss in detail. That's a good idea. But for now, yeah, what we want to discuss is about Redis. So yeah, so let's say that payment etc is one thing. Let's say we are not handling the payment now. We are just handling this thing. We are reading the state, we are updating it to -1, and this is a transaction in itself. Now 10,000 users are trying to do it for 1,000 items. So you can't just keep on like holding this transaction forever. So what you have to do, first of all, you can't just keep on making these calls to your database. So first of all, you need a highly available Redis instance. So that is one thing. You can't have a single instance. You must have a cluster with all the replicas in place. So even if like one like the leader fails, the followers can then take over. So you must have like a proper replica based setup, and this is also something that I have discussed in one of the sticky sessions related tweet that I just did some time back. um, and it was about like if we have like session based authentication and everything is stored in Redis, so that is also wrong. We need to also store it in database, but that is another tweet. For this one, you need to store the state in Redis, because you can't keep on making the calls to your database. So that is one thing. And once you have that item stored in Redis, you can then have a Redis transaction. So the thing about Redis is that it is threaded. So there is a single thread, kind of, you can think of it like an event loop based system. So there is this only one thread that does all the operation inside Redis, and it is very, very intentional. So that one thread, like let's say a request comes in, then you will open a Redis transaction. So in that Redis transaction, you will then read this key, you will update it, and then you will just return it back very quickly. And it's very easy to code also. Maybe I can do this in the next session. um, so yeah, so that is one thing. And let's say that if even if our main primary Redis leader crashes, we will have like replica based thing. And I think there is this redlock algorithm or something, which is like this distributed log thing where we just uh, so this is something that we can read about. I'll not go into this. I think it uses this internally, the redlock algorithm. uh, when like there are multiple, like let's say that we have n redis masters, and then we have like leaders, like n leaders or n masters, and then we have like these slaves. This is obviously not the correct wording because I think this is deprecated, but yeah. So like if we have some main nodes and then the follower nodes, and obviously like we don't want to just depend on our master node, so we keep like lots of replicas. So how do we make sure that whenever something is committed, it should be committed to like two-thirds of the nodes uh, to like assume that the value is committed. So this is how internally it works, but we don't have to worry about this. So basically we have like a Redis cluster. The Redis cluster is highly available, so we don't have to worry about our cluster going down, and we can simply like just keep on opening the Redis transactions. So I don't, maybe I can Redis transaction. So this is pretty cool. We have this multi command, um, or multi or exec, or I think a combination of these. Okay, so what we want is that we want some like atomic uh, thing. So like let's say we have two, like we have this one key which is so we have this one key which is Nike, and the count is 1000. So we have 1000 Nike shoe pairs available. So we will just like start a multi transaction session. Like we will just run a multi command where we will execute some transactions here. So the first one will reduce this um, Nike count by -1, and only after that the second request will take over this and reduce it. Uh, so yeah, so you can just read about this, but mm, yeah, and then watch is also a very cool command. So like these are things that I'll discuss later on, but for now, just to discuss about this problem, so we have a highly available Redis setup, and all of our items, the hot items, are stored in Redis, and we are just changing the counts basically in Redis itself. And then after that, from time to time, we will have to reverse update the database, because obviously like databases are source of truth. And then there is this problem that what happens when this key expires. So first of all, keep the expiration for a longer duration. But even, let's say like, if this is if this expires after 15 minutes, then what happens is that after 15 minutes we will be again checking our database, and our database has the value of 1000. So 1000 in our Redis became 998, let's say, and we did not update that value in database. So obviously this will be a very big problem. So what we can do is that whenever an event comes in, like whenever a request comes in, and now this is getting very uh, yeah, so whenever a request comes in, first of all, we must have a source of truth. So we can just uh, write that request to Kafka also, because that request will be used to update our database too. But I don't think that is a perfect solution. I think what we are going to do is uh, we are going to make the transaction change in Redis, and then we are going to write it to Kafka, and then we can return it to the user. Whatever we write to the Kafka will be written over to the database eventually. So we know that even if our Redis keys are stale, we can fetch the value from the database. But again, this is not the perfect solution. The perfect solution here would be to refresh those keys in Redis, because during this 15-minute window, obviously this thing won't. So again, we have to think about the business uh, side of things here. So this happens like, let's say, every Friday because there is a Friday deal or a Friday sale. So we need to be prepared for that. We should have like a playbook in place that all these hot items must be moved to Redis, and our Redis should be highly available. And then after and the TTL should be like 20 minutes, and after every 15 minutes we should still keep, or we should like keep the TTL to 30 minutes only. Like let's say that the sale goes on for 15 minutes and we will keep the TTL for 30 minutes. So we know that obviously like uh, we are crossing that 15-minute window, and we won't have a problem just operating on Redis cluster itself. So like during that 15-minute window, Redis becomes our source of truth, and we will then flush it to database later on, so that we don't like obviously like we need to keep our source of truth updated. uh yeah, so that is what it's about. So the correct answer here is that we must handle invalidation. We must handle invalidation. So that is the answer here. Uh, and also like connection pooling, because we are going to hit database a lot at some point of time. So that is also something that must be implemented. And then there was this other tweet like we have this session in Redis. So again, what happens is that there are two kinds of login based systems. So one is this like JWT token authentication, which is completely stateless. So we just give a token to the front end with which it can log in at any point of time. And if the token is like valid for 15 minutes, that login window would be 15 minutes by default. But what happens is that we can also have like a session based authentication where we just like give the refresh token as well as the access token. uh, so the access token is kept with us, and then there is this refresh token and everything. So basically what we have is that we must store the session, so we can like invalidate the session, or and we must check it like against our database. So like to make it faster, people just keep that token in Redis itself, and then we check Redis against that. But uh, yeah, but let's say that our Redis restarts. So obviously like we must have a highly available Redis cluster instance. We cannot just simply depend on one Redis with no backups and anything. So that is one thing. And the second thing is that uh, yeah, so our database should be a single source of truth. So whatever we do, we must transfer, like we must keep that data in database also, because like this is a stateful information. Obviously, like in modern times, if we have a highly available Redis cluster, we don't need to worry about it. But we must eventually save that session information to our database, because in the case that if Redis goes down or is unavailable, we can rely on database at least. Um, so that's the thing. Okay. So like these are the two problems that I wanted to discuss today, and this is a pretty late night session. I think yeah, so it's 2 a.m. today. Uh, for now, I'll just end the session, but it was fun. I'll keep posting these kinds of problems, like some nuances of some internal system design problems that you might face in production from time to time. These are not very straightforward problems like design Instagram. So like I know like those are the system design problems that are asked in many interviews, but my focus is not that. I won't ask you to design Instagram. I would give you the exact problem that you can face at scale, or you can face while scaling your systems. And I'm not saying about like million traffic or whatever, but even like trying to build a correct system so that it can scale efficiently without facing any downtime or any problem or affecting any of your existing customers. So yeah, we will be discussing these problems. And first of all, very I would like to say thanks for participating in all these discussions. It's fun to like read all the answers. I try to reply to each and every comment that I have an idea about, and even if I don't have any idea, I try to use Grok here to like answer that. uh, so yeah, thank you for attending this session, and no pun intended. I'll see you in the next one.